Hello again, it's Jason Robb with Amexstra Incorporated, and for today's topic, we're going to address rod ring. And I figure we'd hit three major points. We'll start with the history, kind of how the material application changed over time. We'll go discuss ceramic versus tungsten carbide coated, and then we'll also just briefly touch on the topic again of regrinding. Now, going back to traditional step cone rod machines in the US, the original material for rod rings was tool steel. In the US, we went from tool steel to ceramic. And I have these two examples here because they're kind of the history of the US in our wire drawing. These are from a Synchro FX13. And I believe it was in the 1980s, when looking for upgrading of material, there was two companies in America that had the ability to isostatically press large rings. And so they kind of did a great job advertising in America. And you had two competing designs in FX13. One that was anti-rotational by center ID aluminum pins. And the other design has a plastic, let's call it rectangle, rounded rectangle that pins the OD. For myself, I prefer the ID anti-rotational pins because they allow much easier regrinding. Now, why did in America we skip right from tool steel to magnesium stabilized zirconia? And speaking to people in the industry, one visit a company with a large number of Synchro FX13s, it became apparent that historically in America, we did not have a good source of tungsten carbide coated rod rings. Any company that could make a high quality tungsten carbide coating. At Amexstra, we have two suppliers from Europe that have been doing this process for 30 or 50 years, and each of them produce extremely high quality tungsten carbide coating that is fused to the metal and doesn't chip or spall. A lot of the coatings I've seen that are lower quality, over time it will chip and spall from the surface of the steel. So in America, we went from tool steel to ceramic. When working with OEMs over the years in Europe, there was some discussion, what's better, tungsten carbide or full ceramic? I remember a very open discussion in Germany at a large OEM in about 2012, when I just really had knowledge of ceramics at that time. And a person that I respect greatly at this German OEM was explaining that, Jason, regardless of the price, don't worry about the price, tungsten carbide coated steel runs better than full ceramic. The debate was at that time that he believed it was because of the surface finish quality. And I assured that with grinding and polishing, we could hit an amazing surface finish quality. Over the years, working on many more machines, I think I've determined why tungsten carbide coated runs better in rod machines. And I actually didn't learn this from a rod machine that got me thinking about the idea. It was on a very fine wire machine, a Niehoff M5. I was at a customer and they were explaining, I was asking why they didn't use ceramics in this application. M5 can make very fine gauge wire, I think 52 or 54 gauge. And they said when they used ceramics, the wire just broke. So they were using a step cone made with a special coating, which we work with the company that produces that special coating as well. And with that coated steel, they could make good quality product without wire breaks. And this got me thinking. I think the main reason in that application where ceramic coating on steel would function and full ceramic would not function is heat dissipation. Ceramic is an insulator. When you're drawing wire and deforming it through the dies, you're generating a lot of heat. On a fine wire, on a step cone, the heat would cause it to soften too much and break. On a rod machine, if we look at your entry speeds, it's actually some of the slowest line speeds we have in wire drawing. So if you have a large steel ring acting as a heat sink, it's pulling the heat from the surface of the wire. And another anecdotal story, talking to old operators, they had two feed machines, one which was step cones, is pre-multi-wire, step cones that were feeding a finer wire drawing operation. And the old operators said they preferred the step cone machines producing versus the ceramic step cone producing machines for redrawing to a finer wire. And I think this has to go with it again. We're getting slightly higher tensile strength, potentially with machines with tungsten carbide coated rings rather than full ceramic, just because the wire has a chance to shed the heat during the process. When it comes to cost, tungsten carbide coated rod rings are usually 1/3 to 1/5 the cost of full ceramic. And the differential gets larger as you go with a larger ceramic. If you have something like an FX13, while somewhat challenging, this isn't really too bad a part to isostatic press and get decent yields. When you start talking about 450 millimeter rod rings, there's a lot of room for failure in the process of making ceramics this large. That's part of what leads to the cost increase. And it's a lot of ceramic material that not only has to be formed, but then machined off. So going back to the original debate, tungsten carbide versus full ceramic, even though I'm a ceramic person, after more than a decade, I agree with the gentleman whose opinion I value highly because he's probably seen more wire factories than anyone. Tungsten carbide coated is better for most applications of rod rings. Over the past 10 years, we have successfully changed more than a dozen rod machines from full ceramic to tungsten carbide coated, and the customers have been very, very happy with the results. To address a little bit about regrinding of rod rings, I have some examples here once again. So here's the Synchro FX13, which we successfully reground. It started off looking like that. You can see material that has not the greatest porosity, but we were able to bring it back to a like new surface finish. Just wanted to touch on as well, if anybody has FX13s and EDR13s, this is a creative reuse of materials. The FX13 and the EDR13 have the same thickness, they have the same ID. The EDR13 has a slightly smaller outside diameter. We can regrind every used FX13 ring to be a brand new EDR13 ring. In addition, we have some examples here. This was a used SAMP 400 millimeter rod ring, which we brought back to as new. And people wonder, well, how often do you how much of the diameter do you have to change? This one is a good example. It went from 400 millimeters to 399.6, which causes no issues with the drawing process. We have successfully reground many rod machines. Here's an example something to talk about as well. This is a brand new SAMP 400 millimeter tungsten carbide coated rod ring. Our coatings have approximately 1 millimeter of tungsten carbide coated material. So if the grooves are not too deep, we also have the ability to regrind and polish tungsten carbide as well. One of the differences too, when we look at the functionality between ceramics and tungsten carbide coated, even though they would have the same smoothness or RA in the finish, tungsten carbide has more grip. Usually when we're comparing a reground and polished ceramic, or say a new ceramic versus a new tungsten carbide, usually the customers are able to drop a wrap, which also creates less friction in the continuous slip process. That might be another reason why tungsten carbide can lead to higher tensile strength finished product, reduction of frictional area in the drawing process. If you have need of a new set of rod rings, we can quote Tungsten Carbide. If we're on a tighter budget or time is of the essence, we can regrind and polish your existing rings for most applications. If you have any questions on rod rings that you might be battling, please feel free to contact us here at Amexstra.